Okay, finally, example 7. Find the domain of r of x equals log of x over 8 minus x base 5. And again, we're looking at a situation where we're doing a logarithm, we're doing domain. What matters to me for a domain of a logarithm is simply the argument. In this case, the argument is a rational function. X over 8 minus x must be greater than 0. The rule is always greater than 0, so you always take the argument greater than 0. But again, you have to ask yourself, how do I solve this inequality? We're looking at a rational function. It has an asymptote at x equals 8, vertical asymptote there. It has a horizontal asymptote of -1. Horizontal asymptotes don't matter, by the way, but it does, it has one. All right. Signs can change anytime it crosses an intercept or an asymptote, vertical asymptote. So if the top equals 0 or the bottom equals 0, we're looking at a position where the sign of this expression can change. That's what we care about for rational function. Once it's fraction greater than or less than 0. Once we get to that point in a rational inequality, if the top of the fraction or the bottom of the fraction equals 0, the sign of the fraction can change. So we have to account for every sign change possibility. And the only weird thing about these is if it does say equals to, you have to put a parenthesis still for the bottom of 0, but since it's just a greater than, it's going to be parentheses for everything. So that little stipulation doesn't come into play here. So the only places where signs can change on that fraction, x over 8 minus x, will be at 0 and 8. All right. So then I do the same thing I did before. I'm going to set up intervals from -infinity to my first one, using parentheses on every one of the intervals, from 0 to the next number 8, from 8 to the next number, which there isn't one, so we go to infinity. However many zeros I have, however many x's I have over there, I'm going to have one more interval than that. And then again, it's just a matter of picking test points. X equals, I'm going to pick -1. I'm going to pick x equals +1. I'm going to pick x equals 9. My goal on picking x's is pick the smallest integer possible within the interval. I could have picked 972 if I wanted to. That'd be kind of crazy. I could pick 2.77 if I want to, but why would I want to? All right, so again, make decisions based on just smart choices. Okay, so I'm looking at a fraction, so I'm going to get something over something. If x is -1, -1 on top, 8 minus -1 is +9. Again, the sign is not important, the number. Oh, sorry, the sign is important, not the number. So negative over positive makes it negative. So that region is no good. We're looking for greater than 0. We throw that one out. X equals +1. I'm going to get +1 on top. I'm going to get 8 minus 1 is 7 on the bottom. Positive over positive gives me a positive. That is good. The third one, if 9's on top, it's positive. 8 minus 9 is negative. That makes a negative result, which is no good. So the domain of this is simply 0 to 8. All right, and again, if you want set-builder notation, which I will accept on homework, 0 is less than x is less than 8. You get a number-to-number domain, small number less than x less than big number. If you get a negative infinity comma number, it's x is less than that number. If it's number comma infinity, it's x is greater than that number if you want to go that route. Again, much more efficient to write. I'd probably go that route. If you watch the study guide, though, you'll see that I use set-builder notation for that one because it didn't specify in the test what to use. So, but feel free to use whichever you prefer, whatever you're more comfortable with. Become comfortable with this one, though. That's a great one to use.